Okay, hi everybody. My name is Sabrina and I'm a junior in biological engineering. First, I'd like to acknowledge my mentors, Dr. Jinxiao Fu and Dr. Scott Turn from the Hawaii Natural Energy Institute, and also thank the Undergraduate Research Opportunities Program for the funding. My project is on the fuel properties of Pongamia pinnata and its suitability as a biofuel candidate in the islands. So, living on an island, it's easy to see that we have a large dependence on imported products, and energy is no exception to this. Hawaii is the most fossil fuel dependent state in our country, with about 80% of our energy coming from imported petroleum products. In 2008, the Hawaii Clean Energy Initiative was enacted by legislators, setting a goal of 100% renewable energy by 2045. Today, we're a little over 20% of our electricity generated from clean resources, which is up from 2010 when it was only 6%. So Pongamia pinnata is a nitrogen-fixing leguminous tree. Native to humid and tropical environments in Southeast Asia, Hawaii is an ideal location for production. A study was also recently conducted and found that it had a low chance of becoming an invasive species here. It can grow easily with little care and can grow on non-fertile and even wastelands. The oil is obtained via solvent extraction and can be converted to biodiesel. Meanwhile, the pods and seed cakes left over after extraction are usually thrown away as waste, but can also be treated and have potentials as solid fuel. So the fuel characteristics of 8 samples from a farm in Wahiawa were determined for oil yield, energy content, free fatty acid, viscosity and density, flash point, and iodine number. Pongamia oil has a notably high energy content of about 38 megajoules per kilogram. This is in comparison to ethanol with a value of about 30 megajoules per kilogram and commercial gasoline with a value of about 43. Other notable properties are the low free fatty acid content and iodine number, showing that the oil has low susceptibility to oxidation, which means it'll have good stability during storage and utilization. As I mentioned before, the seed and pod cakes are usually thrown away after extraction just because they are poor as fuel sources. You can see that the energy content is more than half less than that of the oil. And we also determined the carbon-hydrogen ratio, which is another indicator of energy content. We're also in the process of determining other physical properties such as grindability, moisture content, ash content, and volatile matter. So untreated biomass like the seed pods and seed cakes face several challenges as solid fuel, including low energy content, high moisture content, and biodegradability. But torrefaction can combat these drawbacks. Torrefaction is a thermal treatment that converts the biomass to a more coal-like material. You essentially heat the samples at degrees of 200 to 300 degrees Celsius in the absence of oxygen. The field characteristics of the seed pods and cakes will be compared before and after the treatment process, and we're expecting an increase in energy content, decrease in moisture content, and improvement in grindability. Basically, the physical and chemical properties of the solid fuel will be changed to increase fuel quality. So as you can see, the potential Pongamia has as a biofuel candidate in Hawaii is very significant. The combustion of the derived fuel products will have reduced carbon emissions in CO2 and carbon monoxide. In doing so, we can also increase biofuels' contribution to our overall clean energy goal. Meanwhile, we can decrease dependence on other economies and increase our state's own energy security. Furthermore, the trees can grow easily on non-essential lands, have a low chance of becoming an invasive species, and are fit for our climate. Most importantly, the oil, seed pod, and seed cake all have potentials as fuel, with no part going to waste. References if you're interested in learning more, and can open up for questions.